This is the fourth part in the series of landslide susceptibility mapping, and this is final one. Today we will calculate weightage susceptibility score for each parameter classes and total score, and based on this score we will classify into high, medium and low susceptible areas, and finally we will validate the output. And if you want to view the previous ones, you can check these YouTube links. Last time we had created stats, that is cross-tabulation of values, and I have copied it in LibreOffice Calc. It is similar as Microsoft Excel, so you can do whatever you do in this LibreOffice Calc in the Excel also. So first of all, let us see how does these stats calculation look like. So if we open this aspect cross, so we can see that the first column represents the parameter class, and second column is whether the landslide exists or not. So the second column comes from the landslide raster, first column from the parameter class, and this is the total area. So I have copied all this data into this Excel file, so you can see here, and in this file you can see that the last row is both the landslide and the data for landslide and the parameter class are null, so we omit this. So we need to find from these all these cross-tabulation data. So this is for NDVI and DWI. You don't need to make exactly same Excel file like this. This is just to show you. So from these we need to analyze for each class. We need to find the area of landslide and area of no landslide. So I have calculated this, and I will show you how we can calculate. So if you do it in Excel, it is a bit complicated, because from this table we want to find for each classes the area of landslide and area of no landslide, and this will be used in calculation of dense class. So this is the formula, dense class by dense map. So this represents class wise density of landslide, and this is whole area of landslide divided by the area of the raster data. So it is constant for all classes, and it is variable for all classes. And I find it quite complicated, because we need multiple VLOOKUPs. If you find it easy, then you can do it here. You can just manually do like this. For example, 0 minus 1 is no landslide area, and for example 1 is landslide area, and 1 minus 1 is no landslide area. So in this analysis part you can just write the area of landslide and area of no landslide. So this is here, but I derived this data not from Excel, but I did in QGIS using a structured query language, but you are free to do as you like. So let us do it in QGIS. So I have this data of r.stats, so let us use this aspect cross. So we will learn a little bit of SQL also. So in this DB manager, if you open this virtual layer, you can find this aspect cross here, and you can see the table. Let us see the table here. So this is exactly same as we saw in this Excel file. Now we want to create this type of data. So let us see how we can do it. We use this SQL window. So if you write simple select, the capital or small does not matter, star from aspect cross. So if you write this, then you will get all the data. Because there is no header, we will get field 1, field 2 and field 3. So for example, if you add where field 2 is equal to 1, so it will find the data where there is landslide. So if field 2 is equal to 1, it means landslides, and similarly if field 2 is minus 1, then it is equal to no landslide. So we need to join these two tables. So what we can do is, so let us say this is no landslide, so we can close it in brackets and it will act as one table. So let us say again select star from, so it is a temporary table from where it will select again. I will tell you why it is being done. So it will give you the same result. So let us say the same thing we copy in next new query, and we write field 2 is 1. Then we will get this one. And we can see that last one is both minus 1. So we need to write one here sentence, and field 1 is greater than minus 1. So that will omit this last row. So now we'll get this kind of data. And so we can join these two tables based on this field 1, where field 1 is same. So this is very simple. If you don't understand, then I'll keep it in the comment section or in the description. So let us say it is table 1, and this is table 2, and also in this also we can add this part, but it is not necessary. It is table 2, and we add a condition, so we will use this table and this table and combine these two tables. So combine is done by some common field. So field 1 is same here, so t1 dot field 1 is equal to t2 dot field 1. So if we execute now, so this part is not necessary. So now we can see that we get the value from both of these, but as we can see we didn't get the 0. So I will modify this one and we will use left join. So in this case we don't write where, but we write on. So if we write this, it will collect data from both the tables, the one with landslide and without landslide, and it will keep the data from first table. That is the meaning of left join. So let us see. We can see that 0 is also included, and from the table 2 there is no value from table 2, so it is null. So now the query is complete and we don't need all the fields, so we write t1 dot field 1 as, so first is class and t1 dot, so we need field 3 from both the tables, so field 3 comma t2 dot field 3. So we rename the field name like as, first one is no landslide, and second one is landslide. So it will just rename the field name. So this is the whole SQL. So now we can see that we have all this data and it is same as this. So I will just copy this one. If we click at this corner and Control C, then it will be copied, and then if we paste here, then this may be different for Excel. So now the value is null, that is why it is null here, and all other values are here. So I will explain what are we going to do. This total area of no landslide is this one, and total area of landslide is this one, and whole total area of raster we calculated by summing these two. So you can see the formula here and here and here. So this is the total area of the region we are interested, and because this is null, we are calculating the division. So it's C3 by B3. So because C3 is null, it cannot divide. And what we are going to do is trying to find the ratio of landslide area and non-landslide area. So we change this null value to very small value, for example 0.001. Then the weightage will be very low. This means that for the class 0 of aspect, which means flat terrain, there is no landslide. That is why it will have very low score. You can even reduce further like this, as you like. And this is the density of whole raster data. So it is calculated by dividing the total landslide area by total area. Or we can just use total landslide area by non-landslide area. So we'll check here. Okay. So I have done a mistake. Total area in certain parameter class means it should be total of this and this. So we have to divide it by B3 plus C3, although it will not change significantly. And the same we have to copy here. So we can see that there is very little change, and weightage is also very little change. And the weightage is calculated by using log. It is natural log, and it remains same. So this is for the aspect class, and from this new weightage we reclassify the further the reclassified aspect. We are going to reclassify the reclassified aspect. So the 0 class we will replace by this weightage value. 1 we will replace by 0.2, and so on. So we will need to create a rules file. So I have created the rules file using this formula. So first 2 is the original value, and third one is the reclassified value. So 0 will be changed to minus 7.848. So in this way we record the original data, or not original but previously reclassified data. We reclassify again, and this is the weightage of each parameter class. So from this we can see which area, for example, this aspect class 8 has the highest density of landslide, and so on. In the same way we will create the weightage for each parameter class. So we will just use this SQL instead of, like, for example, we just put NDVI cross here, not here but in the main window, and we change this so NDVI cross is here, so instead of aspect cross we just write and we copy this part here and everything is complete. So we have this class 1, 7 and 8 we don't have landslide, so copy this one and for this NDVI, so this is here, and like before we write 0.0001 for this, and then copy this part from here and copy this part from here. So because this so it is C14, so we have to change this to I13. So that is the only thing that we have to modify. So this part we don't need. So this is the weightage for NDVI. So forest area etc. has very low weightage and most of the landslide occur in this area. And in this way we create the new weightage file and rules file for each classes. Now you can see that I have copied this parameter class wise landslide area and non-landslide area from this QGIS. You can see that all the stat CSV data are here, and I have changed this each time and then copied from here to here, and accordingly I have also copied this part and this part to all these parameters, and I have calculated the weightage, and finally I have created the rules based on the same. For example, I have used column A for the original and column E for the output. So you can check this, column A for the input and column E for output. So for each you can see the columns are different, and from this rules I have created the rule file which I have kept in the rules_2. So to differentiate between the file names, like in the rules file I have used rule.txt, and in case of this rules2 I have changed the file name so that it will be clear. So I have added WT in front of the parameter name. So we will use this to reclassify again. Now this is our Grass-GIS interface. So I will use r.record. So in this case we are going to input equal to reclass dot, let us check the command. So input equal to recl dot slope and output is equal to wt dot slope, and we use the rules, so we can write this again: recl dot slope and output equal to wt dot slope, and rules equal to, it comes from here, rules 2, Control C and Control V, and slope is slope weight dot txt, and we need to change this slash so this is a spell mistake, so record. So now it has run, and in the same way we change only this part. Slope is now aspect, and this aspect, and this part is also aspect. So we need to be careful here. So aspect is also changed. When we can also observe the change here. Similarly, we change the NDVI. And similarly NDWI. Slope, aspect, NDVI, NDWI we have done. So remaining is P curve. So let us check the data. Prof curve, and output also we write the same, and the rules file is P curve. And in the same way we use tan curve. So copy and paste, and we use tan, and now remaining is the river distance, so RDIST, and here also change RDIST. So RDIST is not here, so we have to check river DIST. So okay, we change this to river. So output will be also same. So now everything is converted. So next part we have to do is sum. So summation of all the raster can be done by using r.series. So we can use like plus, or we can use this. So for using plus we have to use map calc, and this may be much easier. So we can do various raster summation or aggregation. So we create various statistics. So in this case we are only going to have a sum. So let us use r.series and input equal to wt dot. So we separate by comma wt dot slope comma dot probe curve dot ndvi wt dot ndwi wt dot rdist, and now we have to write output. So output equal to sum of weight, so we name it sum wt, and method is sum. RDIST is not found, so we change it to river DIST. So this is the final sum of all the input. So from this we calculate the overall score, or we divide it into different susceptibility classes. We have created a landslide susceptibility map based on the weightage for each parameter classes. So let us try to understand what we have done. So in this analysis we assume that the ratio of landslide in every class decides the score. So for example, we have this ratio of landslide area with total area in this class. So for example, the aspect class 1, which is east direction in Grass-GIS, has total area of this much, and the landslide area is this much. So based on the ratio of landslide to non-landslide, the total area, not non-landslide area, but total area in this particular class decides the score. So all the bivariate analysis of landslide susceptibility mapping is done based on this concept. So we can consider that we have already prepared the susceptibility map. This is the coloring is done by using quantile. So I have created a quantile. Quantile means we find the or we divide the whole data in 4 parts such that each part has same area. In this case, we are going to divide the sum of weightage in 4 different parts, and it will be written in this q005.text, or for the 4 number of quantiles we say 4. So if we run this one, the file will be returned to this text file. So let us enter this one. So the data is saved in this quantile part. So this is q004.text. So if you open it in text file, you can see like this. So from the score 25 minus 25 to minus 1, 25% of data area exists. So for example, minus 1 to minus 0.3, the 25% area is covered, and so on. So we color according to the quantiles. So for example, we set color table interactively, and then for example, we can clear all this because I have already added these values. The lowest score is blue, next one is green, and then yellow, and then red. Highest score is colored as red. So let us do it. So clear all, and we check this quantile. So minus 25 to minus 1.1, we will color blue, and so on. Now let us add the colors. So we have four divisions, and we will have 5 distinct values. So minus 25, 1.1, 0.35, minus 0.15, etc. So we will create 5 colors. So add, and first one is minus 25.1, second one is minus 1.06, third one is minus 0.34, fourth one is 0.143, and last is 0. So we give them colors, like the lowest one we give blue, next one we use green, third one we use orange, or this one, fourth one we use yellow, and the last one okay, we use red, but the value should be 2.47, 017, so 2.02, I had made a mistake. So now we click apply. Now this is the map we wanted, so okay. So we can see that this is the susceptibility map, but we need to validate it. So the red parts are supposed to be most susceptible. Now let us follow this landslide tutorial. The last part so I have written Python codes, but let us do it using percentile, and so we create a percentile, so the same quantile can be used with value 100, so it will divide the whole data into 100 parts with equal area. So let us use this one. Now in this we use the r dot quantile, and this time we use 100, so it will create a percentile, and we write it percentile dot text. So now enter, and the percentile data is created. It is in this form, so we can see that the percentile data in this folder. So for example, -25 to -10 score covers 1% of data, and so on. So it is up to 100%. So let us color the data, or we can reclassify, because it is in the format of recode. So we recode the data, for example, -25 to -10 as 1, and so on. So let us do it by using recode. So r dot recode. So the input is sum of weight, and the output, let us check, quantiles. So for recode we use input, output, and rules. So let us use this command, output equal to sum weight PC percentile, and rules equal to we use this percentile as rule, Control C, Control V, and percentile dot txt. So now we can see the divided area. So for each single percentile, we find the area of landslide. So that can be done by using r dot stats. So we will use the same r dot stats formula. So this is the r dot stats. So we copy this one. So our output name is different. Here it is written WT quantile, but I have created some weight PC. So I will change this one. And we use this LS raster so to compare with the landslide, and output will be something in the stats folder. I will create the sumweight cross.csv. So all the formatting and everything is done here, so we just click enter, and we can see that this sumweight cross in Excel or any spreadsheet file. As we had created the parameter class wise landslide distribution, like existence or non-existence of landslide, in the same way we find the area of landslide for each percentile. So I will show you how to do that. So I have this QGIS, and using DB manager I have opened this sumweight cross already, and we will use the same SQL. So copy and paste here and change this to sumweight cross here also, and we need to reverse. So we order it by T1 dot field 1, and it should be descending. So but these fields are treated as string, so we need to convert into integer, and if we run this one we get the landslide ordered in this way. So we change the name of field 1 to percentile and execute again, and then copy this, Control C and new sheet, Control V, and we get this one. So we find the cumulative of this one. Maybe we can use this column. So cumulative is equal to this one for first row, and from the second row we add this value to the previous one, so we get the cumulative landslide area. And because the value is error, so we need to change this null to 0. So Control H and null to 0. So all the value are now correct. So To get the graph like this, we start the top score as 1. So let us create one PC from top score. So for the first one, 101 minus this one, and we will copy this to up to down. So we can create a graph and copy this, not copy but create a graph using this chart. So data series, the chart type we use XY scatter, and it is okay. So now we can see that our graph shows the area of landslide by percentage. So first 1% covers 30,000 square meter, and so on. So we can change this cumulative percentage area and equal to, for example, we can sum this area up to here. So this is the sum. So we can calculate the percentage by dividing this slash this, and this should be dollar sign. So the data range we can change. Data ranges we can change, it depends upon the software. So for Y values I will use F column, and name also from F column. From this we can see the characteristic of this graph. So first 20% of the area covers around 70% of the landslide, and 40% covers 80%. So we can get or create the susceptibility scoring based on this, but the result is not quite good, because up to 50% we have only covered 85% area. But anyway, we will use this rules file and create a new rule. And we save it as percentile rule, not percentile but percentile rule dot text. And then use this. I had already calculated the susceptibility, so I will do it again. So this is, and I had already created this PC to susceptibility.text in the rules too, so you can see that the first 50% percentile, so you can see that we have used this graph. So percentile, actually this is the from top score. So from the bottom, if we see in the percentile raster data, it starts one from here. So for example, up to 50% percentile, we can keep it as low susceptibility zone, and from here up to 20% we can say medium susceptibility zone. So we classify the percentile raster using this scoring rule. So 1 to 50 percentile will be low susceptible zone, and this will be medium, and this will be top susceptibility zone. So I had created this susceptibility raster based on this percentile. So this is susceptibility exists, so we will override, and so now if we add the susceptibility, it will be like this. So we can change the color. So we have 3 values for this final map, so we can use the select color table interactively. As I had already done this, it is showing this color, so we can redo by clearing all and adding this. So 1 means low susceptibility, 2 means medium, and 3 means high susceptibility. So we color it like this. So if we apply, so we get this kind of susceptibility map, and this is our final susceptibility map, where red areas show high susceptible area, yellow medium, and blue low susceptible zones.